Hello. Can you guys hear me?
Yeah, hi.
Yes.
Yes.
Good morning.
Okay. Okay. So today, yesterday I mentioned, right? So this is the course structure. So I hope you guys, I've shared this in the WhatsApp group also. So this is a course structure for you guys. So you guys can follow this. So these are the topics we will go through. If you see over here on page number 14, did you guys have a chance to look at this? Right. So basically we'll focus today on the second part, right? So basics of the first part we have covered, and I will take the assignments in Python. So that is one thing. And generally this is the flow, right? So for example, we'll learn more about descriptive statistics today, right? So how do you describe, how do you summarize a set of data points? What is a central tendency? What is a measure of dispersion? What is mean, median, mode, kurtosis, skewness, right? How do you compute standard deviation, variance, and types of distribution? Then coming to your practical hands-on, what is a box plot? How do you do histogram, bar chart, right? So exploratory analysis, like the basic exploratory analysis, right? So this is the second topic that we'll discuss. Now, after that, we'll discuss inferential statistics. So descriptive statistics means it just describes, right? So some descriptive statistics, that's like describing a person, like he's tall, maybe he's 5 feet, and maybe he's a little bit dark, right? It's just describe. Inferential statistics is where you'll start inferring about the person. Okay, so this guy looks like he's working for this company. This guy looks like, you're inferring some information. On the similar lines, whenever a data set is given to us, we'll start with descriptive statistics, then we'll do some plots, then we'll try to infer some statistics. So most of the times, uh, so there are different types of applications in data science, right? So sometimes if you're working as a business analyst or a data analyst, or let's say there is so many other types of profiles, there is machine learning engineer, there is deep learning engineer, right? So there are NLP engineer, so many things. So the focus of statistics will be more in roles like business analyst, where they will be working with, for example, let's say sometimes they directly work with CEO or CTO, right? So what they have to figure out is they have to figure out these. Sometimes they have to do hypothesis testing. Sometimes they have to use packages like SPSS or like MATLAB or all those things. Sometimes they have to write code for that in some companies, right? So basically, let's say they have Facebook ads, Google ads, so they have to come up with marketing plans and all those things, right? So there is some machine learning there, but most of the times the focus will be on statistics. But if you come to companies like product based companies, there then machine learning, like all these concepts will be used more, right? Machine learning engineer, deep learning engineer, general ML engineer, and all that. So that is the reason you guys study statistics at the same time. You build upon the statistics concepts that you have learned on statistics, and learn more about machine learning. So any questions on the flow, guys? I think there was some concern yesterday in the WhatsApp group. So this is the structure that we'll follow. And this see, all the relevant information can be found here. So whoever has access to this, if you log in here, I generally upload all the things, necessary things that I have discussed in the class. So if you go here, for you, I think it will look a little bit different. But if you go here, so this was the class recording yesterday. Yesterday was 18th, right? Yeah, this was the class recording yesterday. And I have written here, what are the things? For example, matrices basics plus expected value probability, right? So you can see here the PDF that I've used for matrices. the PDF that I've used for expected value. At the same time, the Jupyter notebook that we have discussed towards the end of the class. Right. So like this, I generally upload. This is the structure I upload. So for example, you can see introduction to probability part 1. Right. So this is what I think I started off with. So you don't have to worry about it. If there is anything missing, you can ask in the WhatsApp group. I'll upload if I forget uploading. I've created a separate GitHub for you guys. So let me share that. So generally, if you are interested in the code that I discuss here, so you can find it here. All the code that we discuss in the class will be uploaded here in one shot. Now, what is the use of this? For example, if I have to open the code here, right? So if I have to open this, now then I have to download it and open in Google Jupyter Notebook and all that. The advantage of GitHub is if you open here, so you can directly see the code, right? No need to download and upload and all that. So you can say, Money, on line number 12, can you explain me what is happening, right? So you can directly tell me, okay, this is a file and this is how the things are going on. You can also see the output of it. You don't have to even download it. Of course, it's a good idea to download, but so how do you download this? So you can directly do clone and you can download zip here, right? So this is how, if you're not familiar with GitHub already, so you can open this github.com and this URL. I'll share this in WhatsApp, don't worry again. So I think I've already shared yesterday. So any confusion here, guys? So before I start with today's class, so what we will discuss, where your files will be and where your code will be. Any confusion or confusion on this?
Mani, do we need to pull these details from the GitHub?
No, if you're familiar with GitHub, Git and all that, you can pull. If you're not
Okay.
familiar, if you're like someone who doesn't know all that, you can directly do download. So if I do download, so the zip will come. So you can just untar this. This will be your files. Right? Whoever doesn't know what is pull, push, create, all that fork. So you can just simply download. Now if you have
Could you please post this URL again in the chat box?
no, you can just scroll up in the WhatsApp, right? You will figure that out.
Okay.
Yesterday only I posted.
Okay.
Any other doubts, questions, guys? Any doubt on the sequence? What is taught, what is not taught? What are the assignments? What are there? What are not there? Any doubts? Any questions? Then we'll start with today's. So this is what we have for today. So we'll discuss descriptive statistics, right? So basically, how do you describe a? I think we have covered most of it, but we'll just cover if there anything is missing. Some things, some of the things I think are not discussed. So, 1 second. Is the flow clear, guys? Like what is being discussed? Where can you find the files? Where is the code present? All those things. Okay.
Yeah, it's clear.
Yes. Before, because in between, if you are like confused or if you miss any class, that is where you can go and figure out. Okay. So, okay, before I start this class, any questions so far on whatever you have discussed? So we have covered the basics of probability. We have covered the basis of matrices, and we saw that how we can use NumPy as for coding in Python, the matrix multiplication, addition, and all that. How do you figure out the shape, reshape? How do you change the shape? What does the shape parameter give us? How do you do a transpose, let's say, all those things. So I hope these basic things are clear so that we can move to the next topic. Any questions on that? Any doubts?
No, it's clear.
Okay. So if you guys during weekend try to do some hands-on, try to do it on yourself so that you will get more confidence, more doubts. Then you can reach out to me on Monday. Like generally the first 10 minutes is for everyone waiting. Right? So if you have any question or After 10 o'clock also you can ask, like once the class is over. Okay, so let's start with today's class. So today's class is descriptive statistics. Can anyone tell me like what could be this descriptive statistics, and how is it useful in terms of data? In terms of data, right? Generally, we'll have to talk from the perspective of data from now on, right? So, can anyone tell me like why is this here? Like, what? How is this useful? And any ideas that you guys get, or since you have discussed to some extent, any ideas that you guys get? Right, if you take the previous example, right, so let's say if you meet someone, so how do you describe them to someone else? They'll say like, okay, he's like 5 feet, maybe close to 5 feet, 5.5 feet. He's lean, little bit fat or something like that, right? So what you're trying to do is actually describing that person, right? So right, so give summary of population in form of graphs, right? So descriptive statistics is like overall or the superficial statistics, meaning that you describe the data, right? You cannot describe exactly, right? So you describe them, okay, on an average he looks somewhere like 5.5 feet, he looks a little bit dark, and then maybe he's a little bit thin, right? So these are the things you can describe a person. So what it means is, next time when you see the real person, you can sort of understand, okay, yeah, this is the person that, let's say, Money has described me. So okay, this might be the person, right? So you, what I've described is only 4 or 5 details, but with that you are able to connect the person in real sense. If I have to give you exact data, this is his exact height, this is his exact weight, this is how exactly he look, maybe his left hand is longer than right hand, exactly, all those things. Let's say uh, he looks a little bit like this person and all that, right? So describe the characteristics of the data, right? So that is the answer. So generally that is where your first step will be. Like whenever a data set is given to you, so we'll do on hands-on, you guys will understand. Whenever a data set is given to you, it is very important to run or figure out the descriptive statistics, right? So by doing that, you will get some intuition, or you will get some characteristics of the data set, right? So that will give you some idea, okay, this person will look like that. In the same way, whenever you run descriptive statistics, okay, this data set looks like this, okay, this is the mean, this is the median, okay, this is what this, okay, all those things. Okay, so I'll go a little bit quickly on these slides because we have already covered most of it. For example, what is a population? So population is, let's say you can say what is a population of Bangalore, or let's say what is a population of people living in Kadubisnalli, right? So generally we don't have enough resources, meaning like the money or let's say the computation power, to generally do all the analysis on population. Generally we take a sample out of it. So that is your sample and population definition. Okay. Now, so let's take an example of IQ. Okay. Now, if you take IQ, so average person has an IQ somewhere between, let's say, 75 to, let's say, maybe 115 or something. Right? So average somewhere around 80 to, let's say, 150. But you can see that all the exceptional people like Einstein and all have exceptionally smart, right? So they have IQ which is more than 160 plus. So these guys are generally towards the right of this particular peak, tail. So this is called tail. So this part is called tail. Okay. So these are called your
Is
tail.
it a graph? This one.
Sorry.
This one is this graph means the x-axis, y-axis.
So y-axis is the frequency, the number of people. Okay. So the majority of the people are is there a question?
Yes.
What is
So
the question?
yeah, in the y-axis the frequency,
Right.
and the x-axis.
Is the IQ. If you give a test, right? So there are IQ tests. So let's say if you score 50 marks or 60 marks or 70 marks, so that is the value here: 50, 70, 85, 100.
Okay.
Okay. So what I'm trying to explain here is, so this is called your tail. So this is called your tail of your this thing. On the y-axis, you have the frequency, right? So you have the frequency. How many people have the count? Let's say 5 people, 10 people, 100 people. So let's say out of 100 people, if you give the test, and out of those 100, if you include Einstein also, right? So Einstein scores somewhere 160, right? Because he's exceptionally smart. So somewhere he's here actually. Right. So what can you tell about Einstein? What do you call him in this particular scenario?
Outlier.
Right. So he's called outlier. Okay. He's called outlier. Okay. Now, can anyone tell me why he's denoted as outlier? Or what reference you can take? Money, this is the reference. And this is why I can say he's outlier. Let's say my IQ is, let's say I'm thinking I'm very smart. So let's say my IQ is 120. So I'm somewhere here. I'm here, money. Will I be called outlier?
No,
No.
Why is that?
because it is in the range.
He's in the range. Okay.
If total number of peoples are 100 and only Einstein is the one who has more than one IQ, more than the others. So he is outlier, but money is into the range of others.
It
Okay.
will be an outlier, right?
The deviation from the mean is like in case of like 120 is not as much as the deviation for the Einstein 160.
So that is the answer, right? So generally, the mean will be somewhere here because that's where your peak or this particular uh, bell curve sort of structure is. Now I'm somewhere close to the mean. I wouldn't say I'm like too far away, but if you take Einstein over here, he's like too far away. So he's like somewhere else only. Like he's out of the picture.
Out of the standard deviation.
Right. So we will discuss more. I'm just trying to give you an idea. Now, how do you figure out who is an outlier and who is not an outlier? Now, you can say money, you are also an outlier because majority of the people have IQ between 115 and let's say 85. Right. So then the discussion will be a little bit different. But we'll come to that. But in general, if you look in this particular graph, so we can clearly see that he's an outlier. Right. So I'll give one more example. It will make more clear. Now, the way you have to always refer in statistics is you have to always see from the mean, right? So mean is your reference point. So the question, if you remember, what will you take it as a reference? So to compare me and Einstein, right? So that is what you have to say that money, I will take mean as a reference because in this area, majority of the people have an IQ between 85 and 115. You would say that, okay, you are considering yourself as a smart, that's fine, but you are somewhat close to the majority of the people. But if you take Einstein, he's like extremely far off from the mean. That is your reference point. Right? So that is how you can figure out if a person is an outlier or if a data point is an outlier or not. Okay. Now, he's out of the average. Yeah. So he's away from the average or the mean of the this thing. Okay. Now, these things we will discuss. So, yeah, this is a good question. So, can you guys answer this? So, let's say a group of class A. So, let's say a group of class A has got these marks. So, let's say one person got 102, and then 103, and 131, 98, and 140, right? Class B also got some marks like 127, 130. Now, if I ask you the question, like which group is smarter? Now, how will you answer this? From the perspective of descriptive statistics. I want you to think in the terms of descriptive statistics because this is data that is given to you, class A IQs of 13 students, and this is class B IQ of 13 students. So I want you to think in terms of descriptive statistics and tell me like how would you say which group is smarter.
In the mean,
Okay, mean. Any other answers? Any other answers, guys? The answer is correct. So basically, how will you compare a set of data points is basically you'll use the descriptive statistics. The descriptive statistics I'm using here is the mean of the IQ scores. So let's say if this is 13, you might see that, okay, overall you can see from the eye that, okay, suddenly it looks like, okay, there are like few sudden smart guys, and then, okay, here also smart guys. Okay, by that you cannot compare. But if you do mean, right, so you will say that, okay, the mean IQ of the class A is 110.54, whereas the mean IQ of class B is also 110.23, right? So they are roughly the same, right? So which means that both class have some little bit not so smart, some extremely smart, some average smart. So overall you can say class A and class B performs more or less same or more or less similar manner, or they are more or less smart enough, right? But if you just look here, there is no way of figuring out. You can say that money class A suddenly looks like they don't have too many smart people, but suddenly there are smart people here, so majority of them look like smart. So you cannot compare like that, right? So there is no way of comparing 13. Now if you are comparing 13, I will give you 10,000, then you cannot compare, right? Let's say this is 10,000 and this is another 10,000. Then you have to go for descriptive statistics. You have to find the mean one here, and you have to find the mean two here. Then you'll say money. So then I can compare like descriptive or like overall I can say mean one is mean two greater or less than and something. Right? So that way you can figure out how do you compare a set of data points. So let's say some set of data points here, some set of data points here, and some set of data points here. So keep in mind, guys, so whenever you get data set, these are the types of statistics techniques we use whenever you want to convey a point or convey a point in your presentation, or try to compare two data sets in your wherever you come across from this point, right? So you need to apply descriptive statistics. Okay, is that point clear for everyone?
Mani, one question in that previous slide. If the mean of B becomes greater because of one student score is higher, so at that time mean changes, right?
Right.
So that's an outlier, correct?
That is an outlier. So we'll come to that discussion actually. So now what is an outlier in this? You tell me the value. What will you consider as an outlier? So let's say this value is not there.
162 will be outlier.
160?
162.
Yeah, so this is clearly an outlier. Now you have to say money. This is an outlier because I see that the average will be somewhere around, let's say 110. And I see that majority of the values, right? So majority of the, 162 is already there. Right, 162 is already here.
Yes.
Yeah, that's a good point. So 162 is already here, and I don't see any value which is in that scale.
Yeah, in case A, class A, it's all same almost. Class B 162.
Right. So looks like there is an Einstein in class B. So that's fine. So, so yeah. So, but the general idea is, so we will slowly dig deeper and deeper and deeper. So right now, what we have learned is the way we can compare is, let's say we can compare mean one to mean two, right? Then what you do is you plot this data, right? You basically figure out some more descriptive statistics. Now, some more descriptive statistics you will figure out is basically, let's say max. So max value in the max 1 here and the max 2 here. Right, so I'm just showing the procedure that you can apply, approach. So the maximum value over here is 140. Okay, the maximum value here is 162. And what was the mean? The mean that you got here is 110. The mean that you got here is 110. right? Here you can say money, something is off the charts. Now I think mean is not a good idea. We have to go for median here, right? So the reason here is I see that the what do you call, the mean of both of them are same. So my initial answer was both of them are equally smart. But then I've used one more descriptive statistics, which is called the maximum value in this. So the maximum value is 140, which is more or less close to the mean. Here the maximum value is 152, which is like far from the mean. So the difference is 52. Then I would say that there is an outlier 162 in the second group. So then mean is not a great idea. Let me go with median. Right? So does that make sense? Now, so that is the procedure actually. Like I was just explaining you how you can compare, but you keep on digging more and try to understand this data better and better when you're trying to compare these two data points. Is that clear? Like how do you figure out if there is an outlier? How do you figure out should you go with mean or should you go with median?
It's money. It's clear.
I will say even the best way of comparing anything is plots, right? So that is the reason you learn about matplotlib, right? So let's say this will be something like this. So here you can say money, something is wrong with these graphs, right? So you can visually see that. So this is class 1 and this is class 2 and this is your maximum value of somewhere 140. And when you plot it, right, everything comes very easy. Everything you can understand easily actually. So this is 162 and your mean will be somewhere here. So let's say mean is 110 and your mean will be here, which is 110. Okay, so visually if you plot this data, so that's what I was getting at. So that is the next half. So when you plot the data, that's where you can compare it to the maximum extent. You can extract maximum information from the data points. You can clearly see this tail is very wide or long, you can say money, but the tail here is more or less like seems normal here. This seems like a symmetric curve, but this particular data looks like okay, there is some outlier. So you can argue that money, there is one outlier. So that is the reason the mean is 110. But if this guy is not there, the class B is not so smart as class A. So that is the conclusion you can draw finally after doing all the descriptive statistics, doing all the plots, right? Now that is the correct answer, I would say. But just for the general discussion, I have given you this example of mean. Okay, so that's a good question. Any other question, confusion, guys? So the main idea was with a summary descriptive statistics, it is much easier to answer our question, right? So instead of just looking at these points and not able to answer, if you apply these descriptive statistic techniques, it is giving you much more information to answer the questions. Okay. So what are the central tendencies in summarizing the data? So which we have discussed is mean, median, and mode. Okay, what are the variation or summary of differences within the groups? How do you figure out that? How does it vary? Is basically with the help of range, variance, standard deviation, and interquartile range. So interquartile range I'll explain more maybe in the next class. So I'll explain a box plot in detail. So you guys will understand what is a IQR. So this is generally called IQR. Okay, so I hope you guys are familiar with all of these since we have discussed this in the first class itself. Mean, median, mode. The only difference in median is you have to sort the values. If there are two values, you have to find the summation and divide by that value. Okay, so the sum of those middle values and then divided by 2. Okay. So mean is very sensitive to outliers. So that's why they have found or invented another technique called median. Okay, mode is for your categorical variables. Whenever there is a mean, male, female, or let's say unemployed, employed. So you want to find the most frequent value. So that is your mode. Okay. So then range is basically maximum minus minimum. Okay. So IQR I'll explain when you are discussing box plot. So variance is basically you will take the reference as the mean. Okay. And then you'll basically this is something like this. Sigma minus mu square. Now, if you're discussing the if you're discussing the population, then it is divided by n. You're discussing with the sample divided by n minus 1. Okay. Standard deviation is nothing but the square root of variance. So standard deviation, if you want to figure out, so then you have to do square root. Okay, I hope these things should be like very, very clear, because you will keep on hearing the words range, standard deviation, variance, mean, median, mode, right? So you can see just now that I've used mean, median to figure out how I can compare two groups of data points. Okay, is that
Mani, so can you explain the variance means? Actually, what we measure by variance? This is the formula that we familiar, but what is the use of variance means?
what is the use of variance? So that is a good question. So, so yeah, so what it looks like is variance and standard deviation like very, very similar, right? What I mean by that is, why are there two metrics? Like why is this and why is this, right? Now, if you understand standard deviation, right? So if you understand standard deviation, what it means is it is a standardized way of defining, let's say, data points. Let's say defining data points. So what I mean by that is defining data points. Right? So with the help of standard deviation, you can say that, let's say if you have these points, so let's say if you have these points, so let's say this is your mean. So let's say this point is one standard deviation away from the mean. So this is the standard way, like everywhere you're using the standard, like the standard for weight is kgs in India, right? So similarly, you know how much 1 kg stands for. Like whenever a data points are given, this sigma or this standard deviation stands, what it means is, okay, this point is one standard deviation away from the mean, right? So this point is, let's say, 3 standard deviations away from the mean. Now this makes sense, Mani. Okay, standard deviation makes intuitive sense. Now why is there extra parameter variance? Now there are two answers to this. So the one answer is variance you can think as a middle step. The middle step for finding standard deviation, right? So this is a middle step for directly finding the standard deviation. Ultimately, you will use most of the time standard deviation, but there are some important techniques called something like PCA, right? So where you will discuss more about the variance, about the you'll discuss more about variance, right? So until then, you will feel that, okay, Mani, variance where and how is it going to be useful? I already have a standard deviation which is giving me more information. Why is there a variance even involved in the describing the variation, right? Now the simple answer is variance you can think of whenever you're looking at so variance is nothing but square of this, right? So it's the squared distance. So squared distance, summation of squared distance from the mean. So that is your variance. And then you divide by n, all that from the mean. Okay. So in high level terms, so this is called, in high level terms, so this is called variance gives me the information. Variance gives me the information. So variance generally gives me the information of the data point. So what I mean by that is, let's say if I figure out, let's say these are my two axes. So let's say this is x axis. Okay. So let's say this is y axis. Okay. So let's say this is 1. Let's say this is 2. Let's say this is 3. So let's say this is 1.1. So let's say this is 2.2, and let's say this is 3.1. Right. So let's say there are 3 points. Now I will not ask you what is the standard deviation along x-axis. I will ask you how. So read this question properly. How these 3 points, how these 3 points, are varying, right? So how these 3 points are varying, okay? How these 3 points are varying along x-axis, right? So if you observe this word varying, right? So what I'm looking for is the variation or the information along the x-axis, right? If you're dealing with these types of plots, and if you're dealing most of the times, then you'll deal mostly with the standard deviation of the things. Did I make it more clear or more confusing? Right, so measure of spread of data points from the mean is variance. So that is correct. Range also will give you the spread of data points. I'm just trying to explain why there are so many techniques and in which case you would go with which parameter. These things will come like maybe after 1 month, but I'm just trying to explain like why there are 2 things and why there are not one thing. Did I answer your question partially at least? Whoever has asked the doubt.
No, actually, means what is the difference between these two parameters? It's not clear.
No, they are no difference. That's what I'm saying. There is no difference. It's just the square root, right? So let's say square root of 9 and 9 is basically 3, right? So what is the difference? It's nothing. It's just square. But what I'm explaining is it's like more like a contextual thing. What I mean by contextual thing is, so whenever I ask you a question like, hey, these are the 3 points, 1, 2, 3. Can you find how these points are varying along a x-axis? What I mean by varying, I'm asking you along the x-axis how these things are spread out, right? You can say money. I will use variance, which will give me whatever formula you'll apply, and it will give me this is how the spread of the points along x-axis is, right? So they are actually equally spread out. So they are spread out at one unit along x-axis, right? Now let's say if I ask you a different question. So let's say this is your mean. Let's say this is 10, and let's say this is your point, which is 19, right? So can you explain me how this point 19 is spread out, right? You can say money. This point 19 is 3 standard deviations away from the mean, right? So variance is also present here. Standard deviation is also present here. Standard deviation is also present here. So if you ask me what is the difference, there is no difference. Both of them are used for finding the spread of the dispersion of the values. But in this particular context, variance makes more sense. In this particular context, standard deviation makes more sense. Both of them are very same. Both of them are, it's just a square actually, square and square root.
Okay. Yeah.
So this is a long answer actually. The reason I gave the long answer is this I've heard from many classes generally, like why is there a variance and why like what is the use of it, right? So there are 2 answers. One is it's an intermediate step for finding the standard deviation. Unless you find variance, you cannot find the standard deviation. And variance you will appreciate more once we discuss high level and complex concepts like PCA and linear regression and all that, R2 score. So we'll come to that slowly, like after 1 month. Okay, so mean, so all these things we have discussed, I will not go through them again. So mean is already here. Sum of the values are divided by the number of values. Okay. Yeah, so this is an interesting example. Now it's already written here, but let's say on the x-axis, I have the income of people, right? Let's say income of people in US. Right now on the towards the end of this tail, so there is the income of Bill Gates, right? So can I call Bill Gates as an outlier?
Yes.
So the
Yes.
reason is, if you look at the tail, he's very, very far off from the mean, right? So this is your mean, and he's like very, 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 very far off from the mean. So this distance is very, very far off, right? So that is the reason you can say that money, the salary of Bill Gates is very, very, very high. The average person's salary is, let's say, $80,000. So this guy is some $2,000. He's very, very far off from the mean. So that is the reason whenever you have outliers like this, so for figuring out the central tendency, mean is a bad candidate for figuring out the central tendency of the data points, right? So mean is a bad candidate whenever you have outliers like this in this particular manner. Now, how will you figure out? Here I've told Bill Gates, you know, Bill Gates is rich and all that. Let's say if I've given you glucose levels, so you have no idea, right? That is the reason you do EDA. EDA meaning you plot the values. So let's say if your EDA looks something like this. So let's say this is a patient who is suffering from diabetes, and let's say this is a patient who has a normal glucose levels. You can say that the person who has so let's say the study is about normal glucose levels, right? So everybody, nobody, I mean, like, everyone doesn't have a lot of knowledge about glucose, what is a normal value and all that. For some reason, if a patient is included in the study, if a patient of diabetic patient is included, so his sugar levels or glucose levels will be extremely high, right? So let's say this is, let's say these are random numbers. Let's say this is 80, and then this guy has, let's say, 160 or something, right? So here, who will you call this guy as an outlier or not? What I'm trying to explain is, whenever a data set is given to you, here you already know that Bill Gates is super rich, and that's why you might be calling him as an outlier. I want you to learn the intuition that whenever you plot the data and you figure out that there are few points towards the end of the tail, these points are probably your outliers. So these points are generally your outliers, because of which your mean will be a bad parameter for estimating the central tendency of your data points. So mean is a bad candidate for estimating the central tendency of the data points. So if you understand that point, that is what I'm trying to explain here.
So,
Any-
Mani, in practical scenario, we will have outliers in the data set, right?
Sorry, question. What is the question with you?
We will have the outliers in the data set
Yeah, you'll have outliers all the time.
all the time. So, mean will not be useful parameter.
Mean, I would say that most of the times you can forget actually. Mean is just there for the discussion purposes, but most of the times you can forget about mean actually.
So, in practical scenario, we will use the median.
Yeah, most of the times you'll use medians for replacing the NA values or finding the central tendency of the values.
Okay.
1 second. Okay. Okay, so that's why we have median, right? So median is basically you sort the value. Sorting is important, guys. If you forget sorting, then median will be wrong. Okay, don't forget that. So median is basically you sort the values, and the center value will give you the median value. Okay. Now, I think you guys discussed this. Can you guys tell me what is a left skewed and a right skew? Can you guys see this? Okay, on the left I have a left skewed, and on the right I have a right skew. Okay, so this is a simple interview question, or sometimes they ask, how does mean, median, mode present in a left skew data set, right? So left skew is nothing but the tail you see here, right? So the tail part you see here will be present on the left side of the data set. Now, because of this, what will happen? Your mean will be present here, your median will be present here, and your mode will be present somewhere here. Okay, is it clear? Now, whenever there is a right skew, whenever I say my data has right skew, or someone, wherever you read online, if they say there is a right skew in the data set, what they mean by that is, so the tail here is longer, right? So the tail here is longer, and the mean will be present here. Since this is not the central point, you will go with median, right? So whenever there is any sort of skew, it is a good idea to go with the median, so the green one, and the mode will be present in this manner, right? So is the left skew and right skew clear, guys? So left skew is nothing but when you plot these frequency curves or histogram, you'll figure out this tail is stretched on the left hand side. So you can say that money, I have a left skew in the column. Let's say this is age, right? So I have a left skew in this column called age. Let's say money, I'm looking at salary value, right? Money, I see that the tail of this salary column is longer and wider. So that's why I will say that money in the column salary, I have right skew, right? What is the property of right skew? Generally, the mean will be right hand side and the median will be occurring here and the mode generally will be present somewhere here. What is the property of the left skew? The mean will be to the left hand side, the median will be towards here, and the mode will be somewhere here. In both these cases, median will give you a real, true picture, like a true central tendency. True central tendency.
Is it not like we remove outliers and make it normal distribution and then calculate or something? Because why do you even go for such a skewed graph, right? My thing is you should remove outliers. That's what I'm saying.
Right. So that's a good question. So should we remove outliers or should we not remove outliers? Now let's say if you remove outliers, so what would happen? It's a question of the amount of data that you have. Let's say if you are dealing with 10,000 rows. Okay, so let's say if you figure out that these are the outliers, let's say there are like 15 outliers or something, right? Now what you will figure out is money, these are the outliers, and let me reduce 15 here, then I'll end up with, let's say, 9,985, something like that. So that is fine. That is a completely valid decision that you have removed the outliers. Then curve will look sort of like this. This is the updated curve after removing outliers. So this is after outlier removal. Okay, on the other hand, so let's say on the other hand, if I have something like this, so let's say if you have 100 rows, okay, let's say you have 100 rows. Now, sometimes it is not so easy, right? So what I mean by that is, so let's say if you have, how many? Let's say if you have 10 outliers here. So 10 outliers. Now this 10 is actually 10% of your data. Now, if you go for the removal of data, you might end up with 90 rows, which is basically you remove 10% of the data here. Right? So that's a significant amount of data. Now, if you see here, this is 15 divided by 10,000. Right? So 15 divided by 10,000. Now, what it means is you have removed like very, very less, like 0.0015% of the data you removed. Right? Here you are removing 10% of the data. In fact, let's say if I make this as 15%, right? So not one outlier. So outlier 1 is here, outlier 2 is here, outlier 3, like that 15 people are here, right? Now, will you remove here? So the question is, will you remove outlier here? Right? So my answer would be no, because if you remove outliers, yes, your skewness is gone, right? Your skewness will become like this, well and good. Your graph will look something like this. But you have lost somewhere 10 to 15% of the original data. 10 to 15% of the original data, and you already have less data, right? So the call of removing an outlier, so whether to remove an outlier or not, completely depends on how much of the information that you are losing. Sometimes you have to work with the outliers. Most of the times you will be in this situation. It doesn't mean you will also fall in this situation. You will end up sometimes in this situation also. So the call that you have to make over there is, money, I have a lot of information that I'm losing by just getting rid of the outliers. So I think it is a good decision to work with outliers, right? So working with outliers. Here, money, I know that I'm just removing like very, very less information of the data. then I can remove the outliers and my graph will look more better like this. And I can work with, let's say, machine learning algorithms. Is it clear, like when to remove outliers, when to, and how to make a call of removing outliers?
Yes.
Yes.
At the end of the day, guys, whatever you do, there is no right and wrong. Of course, you can come back and say, Mani, all the time I ended up in this situation. You told me in the class that there is this situation. The reason is nowadays there is a lot of data all the time. So of course, outlier removal is fine. But sometimes if you're working in, let's say, COVID-19 patients, right? Or let's say some vaccine development, or let's say some healthcare, or let's say your company is making very, very few products, or you don't have a lot of information, it is quite possible that you end up in these situations also. It's little bit less, but in this, the thing or the takeaway here is how much information, original information, am I losing by removing outliers. Now keep in mind, all the advanced techniques like deep learning, machine learning are fine with outliers. So they can sort of figure out, okay, I can see that there are outliers in the data, so I can figure out and work with them. They won't give you like too much impact on the data, right? So, but you have to keep this point in the mind, right? So always remember how much information is lost by removing the data. It should not be that the original data has a lot of information. Just because you are going with outlier removal, you lost a lot of data, then it is wrong. Okay, that will give you completely different results. Okay, so I hope the left skew and right skew is clear. So this is interview question, guys. So if you can answer this, then that guy or whoever is asking the interview will know that, okay, when there will be a skew, and you understand the placement of mean, median, and mode. Any questions on this left skew and right skew? Any doubt or any question?
If they ask what is right skew means, we specify with the position of mode, median, and mean means. That's fine, right?
Yeah. So you have to explain that right skew is the tail. You understand tail, right? So this is the tail will be stretched out, and this is the reason the mean will be on the right hand side, and median will give me the true measure. And if you draw this, if you get a chance, if you have pen and paper, if you draw this, that is fine. Or else when you explain tail will be longer on the right hand side, you get already full marks.
Okay.
Okay, so let me go back to the slide. So that is your left skew and right skew. So these slides generally have the same thing again and again. Okay, so that is in real life, guys, never ever think that you will get a data like this. Real life is all about skewness, and there will be outliers, and there will be a lot of cleaning required. So this is symmetric is not even happening in most of the cases. Okay, now so we have this. So mode, can anyone tell me like in which example that I will go with mode? Like what is an example, like any example?
Online shopping, whether this particular gender is going to buy what?
Which gender is going to buy what? Okay, that's a good example. Okay, so let's say if I have these values, let me see how much you guys know. What is the mode here?
All are unique.
0 mode.
Is it no mode?
No, mode is there.
That's what I meant.
Itself is mode.
Or everything is mode?
No mode.
Okay. Okay, so these are questions that I want you guys to figure out. What about this case?
Mode is 2 and 3.
2, 3.
Should it be one value or more than one values can be mode? That's
Yeah, you can have more than one mode, Surendra.
okay. Then it should be 1, 2, 3, 4 in the first case. Yeah.
No, mode is most frequent, right? So 2, 3 are occurring 2 times.
Correct. No, I'm saying in the first case.
The first is okay.
Yeah, all are unique. So 1, 2, 3, 4 is the mode.
No, the question is some people are saying there is no mode, and I am saying let's say there is 1, 2, 3, 4 is also the answer. So what I want you guys to is figure out.
Okay. What is correct? Okay.
These are just small like things like statisticians have figured out on that. You can say argue that money mode is this. Some people say there is no mode because there is no information that you are gaining, right? So how can you say this is same as this? It doesn't make any sense, right? Mode is something that is the most frequent one that you have to give me, because among these you are giving me back 2 and 3, right? So that makes sense. But here you are giving the same thing back. So I want you guys to figure out like what is the answer. So there is one more question you can get here. Yeah, here. One second. Yeah. So what about here?
1, 2, 3.
1, 2, 3.
1, 2, 3. Okay, so that's fine, guys. So keep in mind. So keep in mind. So I'll explain you from a practical standpoint where we will use all these concepts. So whenever you get columns, so whenever you load a data set, whenever you get columns, so there are 3 types of columns. Can anyone tell me what are the 3 types of columns? So let's say if I give you a CSV file.
Yeah, categorical and
Numerical, categorical,
What is the third one?
binary.
No, that is categorical. No? Numerical column. Categorical column.
ordinal or something? No.
All of them are categorical.
Is it data?
Alphanumeric.
Continuous.
This is called continuous. This is another word for it. Ordinal, nominal, all of them come here. What is the third one? Let's see. I'll give you 2 minutes. Think outside the box. Hope you guys are following me. So let's say if I give you a data set, one column is age. Age will come here because there are numbers. One column is gender. Gender is categorical. Will come here. One more column is salary. It is numeric or continuous. Salary will come here. One more column is, let's say, weight, right? It is also a numeric or continuous. Weight will come here. One more column is marriage status. Let's say married or single. That's a categorical married or single. What is that? What is that?
Date, time.
Yeah, that is the right answer. Time series. So time series data or time. Okay, keep in mind, guys. So there are 3 types actually. So generally, you will discuss or learn more on this side only. So there is time series also. Sometimes you will work with time series data set, meaning that on the x-axis, or let's say on one column, always there will be date. Like on day 1, what is the sales? On day 2, what is the sales? On day 3, what is the sales? On day 4, what is the sales? So this column will go here. This is not numeric. This is not category. This is a time series column. Is that clear? Yeah, the reason that I've explained this is, so here you will work with mean and median, right? For missing values, for all that. Here you work with mode. Okay, so there are some more techniques here. Similarly, you can figure out how to replace the NA values in time series and all that. But generally, mean and median is used with numeric or continuous columns. So it is important to identify money. So these columns are numeric and these columns are continuous. Categorical. Okay, money, this column is time series. So if you understand that, you will have a clear idea of approaching the problem at hand. So these are all different types of descriptive statistics. Now let's say if
Money.
yeah.
Yeah. So numeric data should be always continuous.
Yeah, that's where I'm going at. So you guys have to tell me here. How will you figure out? This is male, female, male, female. Now, can you guys, let's say I'll put this also. So January 1st, January 2nd, January 3rd, and January 4th. So let's figure out what are what columns. So can you guys tell me what is what? So what is this column?
Time series.
This
Time
is
series.
yes. What about this one?
Categorical.
Categorical.
Categorical cat. What about this one?
Numerical and continuous.
Continuous.
No, both are same. Numerical. Let's go with numerical. Now what about this one?
Discrete.
Think and answer. Think and answer.
Discrete.
What?
Discrete.
Discrete.
The words are differing, but both of them are same. So numerical also means continuous. Discrete also means categorical. So numerical is equal to nothing but continuous. Right? Categorical also means discrete or any other word you guys have. But there is a catch there. You guys have to think and answer. Is it categorical or continuous? If you say anything, I want reasoning also. Don't say just categorical, but explain me like why it is categorical. This is not time series. Let's get rid out that idea, right? So that is not time series. So half of the, like 1/3 of the answer is gone. So we are left out with continuous or categorical. So which one is this? C1.
It's categorical.
It's categorical.
Categorical.
It's both. It's both.
It's both.
Ordinal and
Categorical.
Okay, so how many people say categorical? I heard. What is your reasoning?
It's a labeled value. It's like a label.
It's like a label. Okay.
Because median and mode won't work on these values.
Sorry, median and?
Mean, median and mode won't work on these values. Sorry, mean won't work on these values.
Won't work as in? What do you mean by that?
For example, if there is an area code, so it's a categorical value. So mean won't work on area code.
Correct. But I've just given C1, right? So how can you say it is area code?
Looking the values.
I'm just asking you to look at these values. And so let's say if I introduce the final answer, let's say if I introduce 2.5. What about now? Is it continuous or categorical? Let's say one more row added.
Continuous.
It's continuous.
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 So everyone says it is continuous?
it is both ordinal and categorical, or it's both categorical and numerical.
It's very contextual, guys. So I can give you an example for both of these. So let's say there are number of bananas, right? You can take 1 banana, 2 bananas, or 3 bananas, right? It is still continuous, right? So let's say this is, I will make it categorical now. The way I can make it categorical is, let's say you take a bus ride in Redbus and they are asking for rating, right? So the rating can be 1, you can give 1 star, you can give 1.5 star, you can give 2 star, and you can give 2.5 star. Just because you see the word 2.5, don't think that is always continuous. Now here it makes sense because it is clearly continuous. There is no confusion. But whenever you get data like this, if possible, if you can get the more information about this column called C1, then it is well and good. If you do not have information about C1, can you guys tell me what I can do to figure out, in this case, categorical or continuous? I hope you guys are following. So for example, here, I can see that these values are spread out, right? So let's say if I put it like this, so they will be like here, here, like here, here, spread out, like there are continuous values. But here I can see some discrete, meaning like categories going on. 1, 2, 1, 2, 1, 2. Everyone told Mani this is categorical. But then I introduced one more value, which is 2.5. Then everyone told this is continuous money. But what I'm saying is the thought process should be in a way. It can also be a star rating, right? So if you go any Zomato or Redbus, so they have a star system where you can give one rating, 1.5 rating. Just because you give 1.5 star doesn't mean this value is actually a continuous. It is still categorical. Now, can anyone tell me a foolproof way of figuring out what is a continuous and categorical? Is this explanation clear to everyone? So or any doubts on this? How will you figure out the types of columns? Or did you guys not understand anything?
Understood.
It's clear.
Okay, so this you will face this situation because most of the times you'll have column name information, but sometimes you don't know. So how will you make a call? Let's say I got a data set which has C1, C2, C3, C4. And I asked whoever gave me the data set, I asked like, can you tell me what C1 stands for? I'm not understanding if it is continuous or categorical. Let's say if the person says, no, I do not have that information, you have to figure out as a data scientist, what will you do? Right? So just because you see decimal points, don't jump to the conclusion that it is continuous. Now, is there a foolproof way of figuring out? If there isn't proper standard deviation, then we could say it is continuous. Okay. Categorical because of repeating values. Okay. So I'll tell you the answer. So if you figure out the number of unique values here, figure out the unique values in continuous column, there will be a lot of unique values because this has a decimal system in it, right? So there will be 1.1, 1.5, 0.5, 1.3. So there will be a lot of unique values. But whereas in case of C1, if you see the number of unique values, it will be some finite set of unique values. The star system that you see in the bus ride rating is fixed. You can only have 1.5 rating, 2, 2.5 rating till 5, right? So you cannot rate more than 5, right? So no matter what. So if you see that behavior in any of the column, you can figure out that the unique number of values that I get in this column are finite. Let's say finite, meaning let's say 10, 20, 30. That is the reason I'm going with C1 as a categorical column. Even though I see numbers here, it doesn't mean that they are always continuous. Is that point clear?
Mani, for numerical values also there may not be unique values, right? It may be a repetitive, like for salary, most of the people may be getting the same number of salary, not very much. So we can't come to that conclusion regarding that unique and not like.
Yeah, so when you see, so this technique I would say that you would use when you have no information about C1, C2 and C3 and C4. When you say salary, you already have some information with the header information with the column. Right?
No, I'm telling that, for example, it is salary, but I don't know whether it's salary or not. I do have a data, so how to categorize whether it's a categorical or numerical. So in that case, I may not find unique values, but still it's numerical, right?
That case you might not.
Hardly after 1 year, there won't be same salary for everyone.
Yeah, that is little bit rare situation, right? Salary won't be same for everyone in my opinion.
Everyone, it won't be there after first year. First year it might be same. After coming to second year, because of bonuses and
leave first
picture,
year.
the data set will never be the same.
Yeah, leave first year. In my team itself, the salary is very different, right? So that's a good question, but a little bit rare. Like very unless you are fresher and
fresher and mass hiring, campus hiring.
Mass hiring. I understand, but it is a little bit rare. This technique I'm explaining more from a general standpoint where it is applicable to the most of the times. Is it clear? It's a little bit rare. Whatever the situation you have given is rare. Then yes, my whatever the technique that I've given is not so foolproof there. But most of the situations, the continuous values will have a lot of unique values. You take salary, you take age, you take weight, you take temperature, you take any of the things. Most of the times there will be
all these
Maybe how often we don't get a data dictionary for a
How often? That's a good question. So how often you don't get a information about data set? That is like, let's say you are a data scientist and I put you in medical, what do you call, medical field or medical data set. Now you have a lot of experience as a data set, as a data scientist, but you do not have a lot of field experience. Let's say if I give you a header column saying that this is
business knowledge.
This is the RNA something, right? You will not understand. Even though you're a good data scientist, you have to apply your statistical techniques to figure out this column is continuous or categorical. It can mean that you are in a very completely new domain. At the same time, sometimes you do get out of 2 times out of 10, I would say, you get data sets which do not have a lot of information. Keep in mind, guys, someone who is collecting the data, he will not even bother that this data is useful or not. He will just find the data and give it to you. He will say maybe this is age or salary, right? He is not sure. But as a data scientist, it's your role to figure out what is age and what is applicable for age, what is not applicable for age. Is that clear? Did I answer your question? You can say 1.5 times out of 10 you don't get information about columns. Most of the times you get information,
Sure.
but you have to take a call. Sometimes you have to take a hard call. Is it categorical or continuous? Because it will affect your complete study from the beginning. So these are all descriptive statistics, right? Many techniques are there. Like for example, this is one of the technique. So actually I wanted to do one hands-on. So these things are already there, guys. So IQR I will explain in when we discuss box plot. So these are just calculating the variance and then the calculating the standard deviation. I think I've covered most of it already. Box plot we'll cover in the next class. But what I wanted you guys to do is do some hands-on in the type of code. So I don't know if you guys what all things are discussed in pandas. I want you guys to do one hands-on so that you guys will get some. So can you guys load a data set? I hope that is covered to you. So what is the command for reading a data set? Reading a CSV file?
Read.csv.
ed.cs.
Read CSV. Read underscore CSV.
Can I do this?
Then you need to pass R parameter.
No, I'm on Mac. So let's say you're on
Okay.
Windows, then you have to pass this. Okay. Can I do this? I can do this, right? So this is the data set. How do I share this data set?
Mani, what are you doing? Are you directly pulling from web?
Yeah, I'm directly.
URL will be different.
Yeah, I'm directly reading from the URL. Can you guys everyone load this? First open your Jupyter notebook. I'll explain the basic, whatever we have discussed in one shot. Can you guys open this URL and tell me if you're seeing the same thing? I've pasted the URL in the chat window. I want you guys to first open Jupyter notebook and open a new notebook. And the first command is basically importing pandas. And I'm using read underscore CSV command function in pandas to read the data that is present online. I generally read from online in class because offline I have to share files, and if I share an Excel file, it will become CSV. If I share CSV, it will become Excel. So much confusion. So generally I host it online and everyone can read it in the same format. So is everyone able to run these two commands at least? So these are like the first step from here on. Every time, this is like very basic. I will not even ask you. You should just do it, these 3-4 steps, and then tell me, Manish, this is the situation. If you guys are getting any error, anything, just let me know. Whoever is on Windows, guys, you have to write the word R. Can anyone tell me what R means here?
Raw string.
What?
Raw string.
String.
Yeah, it means raw string actually. You're telling Python to treat this as a raw string. So if you're on Mac, you don't have to do this. You can directly use the
Mani, can you paste the link?
Yeah, paste it in the chat window.
Or chat window.
You guys discuss pandas. How confident are you?
Yeah, Mani, I can read the file.
You can read the file?
Yes.
Yes, we can.
Syntax error EOL while scanning string literal. Yashpal, I think
Yeah, even I'm also getting C.
it's in like this. You have to put it in quotes.
35 rows and 4 columns. That's the setup right now.
Okay. Any errors? Any other errors? Did you fix that error? No, don't fix it here. But syntax error, end of line while scanning string literal. So it's a Python error, which means that. Let me reproduce that for you.
So UL while scanning a string lag.
Yeah, that is what I'm saying. So if you get this error, it means that you have started a quotes here, but you forgot the quotes towards the end. So you have to close here. Let me copy this one. It's important to remember, it is important to get familiar with the errors actually, right? So that you are not stuck, right? Let's say all of them are able to load and you are stuck, right? So it's important to make sure that the way you're writing the code and make sure the braces and all that. So these small things actually waste a lot of time actually. I've noticed that a lot of people generally are stuck. Like let's say they make an error here, so they don't copy properly. They get all these errors. So what does it mean? It means it's a URL error. It means money, there is a mistake in my URL. Right. So sometimes what happens is they forget this part, like forget the quotes here. They start this. It's clearly showing like syntax error, end of line. EOL means end of line while scanning string literal. Right. So string is always should end with the closing and opening quotes. Right. You have to close like this. Right. Sometimes you forget this also. Right. So unexpected end of file while parsing, which means your bracket is missing. So there are so many errors you can run into this. But I hope that error is fixed, whoever has posted. Is it working for you, Yashpal? Keep in mind, don't run into these errors. Okay. Now let's see if I can do all the descriptive statistics. So what is the command for running descriptive statistics in one shot? What is the command?
Right.
Describe.
So how do I find that?
Describe.
tf.describe.
Like this?
No, open and close function. Yeah.
Okay, guys. So all the things that we have discussed for 1.5 hours and till now, can be done in pandas with the help of just one shot, so which is called df dot describe. Okay, so this is very, very important. I think someone is mute. Okay, so all the information, count, mean, standard deviation, minimum, quartiles, which is 25%, 50%, 75%, maximum value, all of this for every column can be found with just this one helpful command called df.describe. Okay, so what does it mean? It means that the minimum tree length is basically, sorry, the minimum, where is minimum? The minimum is basically 1, the maximum is 5, and the average tree length is 3, right? So the age, if you take age column, so the maximum age that the orange, so this is an orange data set, like the data set about the orange tree, right? So the orange fruit, sorry. So age of that plant or the fruit is, let's say, 1852 maybe seconds, and let's say the mean is 922. What is the minimum age? Let's say 118, right? So what is the standard deviation? 491, right? So what does the count give you here? Count gives you the total number of rows that are present here. Okay, so this is very, very important command, guys. So if you run this command, it will give you a lot of information, and it will give you a lot of, for example, a lot of information about mean, for example, standard deviation, minimum value, maximum value, where is the 25 percentile, where is the 50 percentile, where is the 75 percentile. Is it
Mani,
clear?
one question I have.
Yeah.
For the count, if one of the column data is missing, means the count will change, or it will be there as same as all the columns?
Yeah, that is a good question. I'm just looking for a data set which has, one second. So the way you can figure that out is, do you know this shortcut? So the shortcut is put the cursor on the describe command, press shift and tab. So descriptive statistics include that summarizes the central tendency, excluding NaN values. Okay, so if there is an NaN value, then it will not be considered in the count. Okay, so if you see that the count is so what it means, data frame dot count, what does it do? It will count the number of non-NA null observations. Okay, so let's say if there is any null value in between, so the count of, let's say, tree will be less than the count of remaining guys. So that way you can figure out Mani. So there are null values in the tree column. So fortunately that there are no null values in this data set here, because of which you will be thinking that all the counts are equal. If there is any null value, there will be a reduction in the count of the columns. Okay, so you can also do df dot is NA. So there are no null values, right? So there are 0 null values in the column unnamed. There are 0 null values in the column tree, and there are 0 null values in the column age, and there are 0 null values in the column circumference. Okay, so this is another way of finding if there are any null values. Guys, but this command is clear, right? So what is the use of this? What information does it give you? And how useful, and all the descriptive statistics that we have discussed till now is present here. Any questions on doubt? df.info will give you what is the type of the column. So it will give you non-null, what is the data type of this, and what is the memory that it is taking in the in your computer. So this is also one more helpful command, df.info. So just give me 1 second. I will find you a more useful data set.
While you're finding the data, one question on pandas itself. We see some are dot shape. It's just an attribute. It's not a function. Describe. It works with the bracket, without bracket, and it gives different meanings, different data. how do we remember? That's the confusion in pandas, you know. So
How
much
do you
to
remember
remember.
what?
How so much to remember? Let's say it's a df dot shape, right? It's
Okay.
not a it doesn't take brackets. It's not a function. It's an attribute. Yeah,
Okay.
right? So now df dot describe also works without brackets, but it's a function only. Yeah, this gives the meaningful. Yeah, now this gives something else. So how do I even
Yeah, that's the main problem actually.
confusion? I'm saying. So for us, like, what is it? I mean, how do I remember so much?
Yeah, even when I'm
Exactly.
also having the same confusion. So how do we differentiate between method and arguments?
Yeah, that comes with practice. But the way you can differentiate is this one. So, for example, the simple answer is practice. But if you want to figure out the correct way is this. So you can do this. So, or you can do this. Different ways. For example, let's say I do this import Keras. Okay. Right? Let's say I don't know Keras. Even I don't know. Now, how will I figure out if there are functions, if there are attributes, and it's not possible for me to remember 2000 functions in Keras, Matplotlib, and Seaborn, then, right? So the way you can figure that out is basically you can do something like this. Generally, you can do something like this. So let's say you can do, the simple technique is you can do, okay. Right, so there are these. Right, so let's say if I want to figure out more about this. So this is a module, right? So this means that it has more functions within it. So let's say, yeah, I understand it is not possible to remember everything. Now let's say this function, is it a function? Is it a variable? So this is a function. So what it means is I can use, let's say, p equal to k dot backend dot like this, because it's a function. So let me go back.
Money, we can get that one using that shift tab, right? It will show us whether it's a function or a...
Yeah, that also you can do, but sometimes it doesn't make sense, right? So what do I understand from this? It says a built-in function or a method, right? So that is a type. So let's say if I write something here, so let's say if I write def money and what about now? Still also it says function, but there is not much information because I am a bad programmer and I didn't include anything useful here. But if you are a good programmer, you will include something like this, this function. So you can have a doc string like this, so that will make it more clearer, right? So let's say if you do money dot, I think I have to declare that as something else. But anyhow, so you guys get the idea, right? So there are, of course, I understand it is not possible to remember all the functions. Describe, does it come with does it come with function? Does it is it a attribute or class variable? All those things. So of course it will take some time, but generally with practice you will remember, right? So these commands, if you work with, let's say, 5 data sets, then you do this 5 times already. df.describe, this one, and df.info and df.shape, and after that you will slowly pick up the most frequently used one. Let's say after 2 months you forgot, is it describe or describe function? So you can just directly click on this and look for the documentation So it shows all the documentation, right? So it shows type method. So which means you have to use it as a function. Is it clear? It will come, the simple answer is it will come with practice. The long answer is the technique that you can remember is, let's say read CSV. Is this the function or is it attribute, right? So you can click on this. So this will show you this is the function towards the end, right? So type function, right? So this is because the people who wrote pandas package, they gave so much information here. So that is the reason when you click shift tab, so you get all the information and you know how to use this. Right, so let's say if I give you a new package, something like this, import as SNS, right? You have no idea about this package. This was not taught you, for example. Now, how will you figure out? So SNS or this. Right, so let's say I have no idea, is this a function? Are there any other parameters, right? So I can see that, okay, money, I don't remember this one. Okay, this looks like a function. Okay, what other parameters does it take? It takes this A, all this extra information. The only thing that I have to send is A, because remaining everything, it will automatically assign those values, right? So let's say this one. So I also have some more helpful information saying what does A stand for? A stands for a series or a one-dimensional array or a list, right? So remaining everything I can figure out, like what is the example. Example is also given here. So example SNS dot this dot of x. So let's say if I do this, let's see what. Right, so this is how your age actually looks like. Okay, so this is how you can figure out. So let's say if I give you one more package, so import money as M. So can you guys tell me how you will figure out how to figure out, I mean, how will you use the function? So you can figure out all the functions that are present by doing dir. So it will give you all the types of function. There are many techniques. One of the technique is you can keep the cursor here, click on shift tab. So if you go to the bottom, it says if it's a function, then you know it's a function. Let's say if it is something else, then you have to do something like dot shape or dot, let's say length or something like that. Is that clear? Or does it help you with the confusion at least?
Yeah.
Okay. It will come with practice. Don't worry about that. Slowly, you guys will pick up. So then you don't have to worry. So the main goal of the exercise was to make you guys familiar with describe. So describe is very, very important command. The describe will give you a lot of information. So let me give you one more URL and I want you guys to take some time. Don't jump to answer and tell me if you are able to load this data set. Do you have any null values? And I want you guys to run the describe command. This data set is related to bank and I want you guys to recognize, tell me if there are any null values. With the help of, are you able to do the describe? Are you able to load the data set? And what is the information you see and what is the information missing? Is there any time series data? So I've pasted the URL, guys. I want you guys to do on your own, load the data set. You can do it in the same notebook or do it in the another one. Load the data set, which is bank.csv with the help of the URL that I've given to you. I want you guys to answer these questions. These are the three questions. These are the three things I want you guys to do. Take your time. There is 15 minutes. don't run into errors. Make sure that you are opening the bracket, closing the bracket, string literal, all those things. Those are the URL is given in the chat.
Something doesn't appear correct. The
appear?
age, job, material. I think
Uh,
those are coming.
So you need to set the separator as semicolon instead of comma. Just we need to pass one parameter SEP is equal to inside quotes semicolon.
Shape is 4521 comma 1. Okay. This is how it is, guys. So if you notice here, as he has mentioned already, the separator is basically semicolon. I think it's called semicolon. The separator in your, I hope you guys can see this. So the separator here is comma, right? In the bank.csv, it is not comma, it is semicolon. Now, can you try now? I want you guys to figure out from here itself. Press this, click on Shift tab, and see that sub equal to comma, right? You have to give that as sub equal to semicolon. Then tell me what is the data set, how does it look? And I'll add one more thing.
Data type is in 64, I guess. Now it came. We have to put separator.
Okay.
Separator semicolon. So we'll get is NA and all. So yeah, we get all the mean, standard deviation, minimum and all.
Okay.
It is correct.
Okay. What about the shape?
Shape, one second.
Four five two one comma 17.
4521 comma 17. Okay.
4521 comma 17.
Okay. So let's wait for 2 more minutes, 2-3 minutes. I hope everyone is getting that.
Shape is 4521 comma 17.
Okay. What about others, guys? Any problem, any issues you are running into? This is how it is, guys. So in general, either they will give you a CSV file. It will not be CSV. CSV stands for comma separated values. But what I gave is actually, what is this called? Semicolon separated values, right? So this is the things that you have to be aware when you load a data set. Now you cannot load all of them in one row because clearly there are 17 columns, right? Now, let me ask you this question. So how many of them are continuous columns? But before that, I want all of you guys, before I ask you different questions, I want you guys to answer. I want all of you guys to answer at least 1, 2, 3, 4 of these basic things. This we will do for every data set from now on. This is your descriptive statistics. This we will do for all the data sets every time. So I hope you guys can run the describe command. So let me also try.
Mani, I had a doubt. Yeah, the doubt is that now we got to know that it is a semicolon separated. But sometimes, like, how do we identify that? Sure, in case if we don't know whether it is a comma separated, should we open the file and check it once? Like, how is it?
That's fine. Yeah, that's fine. You can open and check it.
Oh.
I hope these two are very clear, guys. These are very, very simple. Now, how come I don't get the other information? I know that there are other columns, but in describe, I only see this. Why is that?
Yeah, it will take only numerical values.
Yeah, so describe generally only gives you information about continuous columns. So if you want more information, then it will give you all this extra information for all of them. But anyhow, it is not useful, but sort of useful, I think. But this is also there, guys. So if you type include equal to all, it will figure out mean, median, mode, standard deviation, sorry, minimum, maximum standard deviation for all the columns. Since there are categorical columns, it doesn't make sense for them to have 25 percentile and 50 percentile. So that's why you see NaN. But generally, if you run this and if you are getting output, that means it's fine. Any questions, any doubt on these descriptive statistics? Any doubt? How do you load the data set? What is the separator? Any question, any doubt? I hope everyone is able to run these two commands.
Can you run that null count command?
Yeah, so the way you can run is df1 dot isNA dot sum. So it will give you per column how many null values are present.
For me, it was giving the complete count. I'm just basing that result as well as the count.
So I think you are doing this, or maybe this.
No, I pinged you the command.
Okay.
Oh, okay. Count I'm using instead of sum. Okay, I got it.
Okay. What were the questions? Shape, shape I think is done, right? So shape is simple, df1 dot shape. So let me see if I do function, what will happen? Tuple object is not callable. Okay. Right? These are the print 5 rows. So this is simple, guys. So all you have to do is df1 dot head. Is this correct?
That is function.
Called bracket.
Okay. So I hope you guys got the basic hang of it. What type of functions, commands most frequently you run when you work with any data set. What is the importance? What are the errors you run into? Now let's say if I remove this, someone told the shape is 1. I run this. If I do df.1, you see what is the issue? Everything is read as one column. Right? That is wrong. Of course, the person who gave you dataset won't say that. But as a data scientist, as someone who has experience with datasets, you need to figure out, even though he told me it's a CSV, of course it is not a CSV. Right? I myself have to figure out. It is very clear to me, right? Because there are a lot of columns, a lot of data.
There can be an issue where like separator is different. So in that case, how to resolve it? Do we have to put multiple separator?
Yeah, there is an option for that. If I ran into that issue once, it's a little bit tricky to explain here, but if I find that URL, I'll share with you. What happens is, that's a good question. So let's say, where is that? Let's say sometimes there is a pipe here. Let's say there is comma here, and there is a what is a semicolon, right? So there is semicolon. Now you have to tell the read CSV command specifically that what column you have to use what type of separator, right? So there is an option for that. I don't remember exactly on top of my head. If I find that URL, I'll definitely share it with you. But yeah, rare situation, but can happen. Yes, definitely can happen. So the question here is, what if there is a comma here and what if there is a semicolon, right? How do I figure out? Oh, if everything is jumbled, okay, you can just ask the person, like, give me back a clean data set. It doesn't make sense, right? You cannot write code for every row and every column. It doesn't make sense. At least some consistency should be there. What I mean by that is there is semicolon, 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 but comma, and then again semicolon. So you can tell pandas that at fifth column or fourth column, I am expecting a comma. So treat that as a separator. That you can tell. But
yeah, but in case like if I have a lack of data, so in that there is a one or two where like some issue is there. So how we will figure out that? Because just by if we will read CSV, so in that it won't show like which column there is the issues, because that data is so much big that by our eyes we cannot catch that.
Acha, okay. So that way. That's an interesting question. So let's say you're saying there is a comma somewhere here and only one place it is present. That's what you're saying?
Yeah. Due to which our data might get corrupted, like some value, like it can be a very important value which we will miss.
Yeah, that is, I wouldn't say that doesn't happen. That also happens. Now, yeah, so the way you do that is then, that's a good question. So what will happen, let's say if there is, I wouldn't call it as an important row, because so the question ultimately comes down to, let's say, how many of these rows does that have that issue, right? So let's say if I am ignorant of that fact that I didn't see the data set, I directly load it here. Then when I work with, so what I'm saying is you might run into this situation where some of the columns are not working properly. There is one more way. So one more way I'll explain. So let me explain. So let's say if I do this, if I don't remember this or if I make a mistake, okay, let's say I made this mistake. The way so let's say this is one way, right? For some reason it worked well also. Let's say df1.info. If I do this, I get some information. It says it's an object, right? So the object means that it was not able, the pandas was not able to figure out. So let me show you the difference actually. If I include the separator, okay, and if I do this, this is fine. You are saying, let's say on row number 1000 there is an issue. When I do this, so this float, right? So this float duration, this int 64, this will convert as object. This will convert as object. Object because let's say if it is integer and there was no what do you call this one, semicolon. So let's say for some reason the guy who gave the data. So let's say what I mean by that is column 1, column 2, column 3, and column 4. So let's say you have semicolon here, semicolon here, semicolon, like dot you have like for many rows. But suddenly there is no semicolon here, there is no semicolon here, there is no semicolon. So like that there are culprits like this somewhere in some places. So let's say like this here. Let's say there is some culprit like this here. So these are all your data cleaning techniques. So this is a one module that is present towards in your course, towards the end of the course we'll discuss. But generally I'll give you an idea. So there are multiple ways. So one way is basically you will see that this, okay, there is no way to figure out like money this is present. The one way is basically when you do df.info. So this particular column. So what will happen, because you gave delimiter as semicolon. Let's say the value is 1. Let's say the value is male. Let's say the value is, let's say 3. And again, let's say unemployed or E. So what will happen is in C1, the word 1M 3E will come. What will come in C2? Null will come in C2. Because there is no delimiter, pandas went red here, red here, red here. Like this, it will also read here also. There is no delimiter, panda doesn't care or doesn't know. So it will keep all of this as one column. Now C1 will have values, let's say 1, 2, 3, 4, and suddenly you will see a value which is 1M3E, right? So I'll show you where and how I can. It's like detective work. You have to do a little bit detective work. So you have to do df1 dot what is the first column? Age. Let's take yeah, you will end up in these situations.
Actually, value comes.
Yeah, my bad. What was that I was checking?
Value underscore comes.
It's completely fine, yes. Even I don't remember. So yeah, so you can see here, right? So there is unknown. That is fine. Maybe unknown word is clearly there. There is student is there. In your case, whenever your data set has like that, yeah, that's fine. Yeah, you can disconnect, guys. I think it's already 10. Whoever wants to disconnect, you can disconnect. I'm just explaining to the doubt who has asked, like, let's say if there are some rows which do not have delimiter or something else. What will happen is when you do this detective work, you will see one more value which is 1, 3, E, something like that. Let's say maybe 1 time. And there is one more culprit, let's say 3, E, and then K, something like that. Right? What it means is there are some rows where these values or some delimiter is not there or something like that. So this is sort of a detective work you have to do to figure out where the column or where this particular data set has any issue. Does that make sense? Like how you can figure that out?
Yeah, so like just to be sure, like whenever we get the data, we need to do some check. Like
you have to always do. That's what I'm saying. You have to always do all of this again and again. It might look like redundant, but any problem that you will see in the future, once you write like a lot of code, if something goes wrong terribly, then you can blame that, okay, Mani, I didn't do proper descriptive statistics or proper cleaning, right? So to not run into that issue, or let's say if you run into that issue, how will you come back is with the help of these commands. So unique values, information, descriptive statistics like describe, shape, null values, all those things. Okay, I can directly do this also. I can do import sklearn as, let's say, sk, and then sk dot whatever, like decision tree dot fit. Then I can also give the column names, let's say df dot age. In one line of code, I can build a machine learning algorithm. But what happens is, if it doesn't perform well, how do I figure out, right? So this is the procedural technique that you should apply to make sure that you get to know your data set much better and better. And then you can take a proper approach, like how do you go step by step. Did I answer your question?
Yeah, it's a bit clear, but I think once
once you get dirt, like unclean data sets, then you will understand the real.
Then we can check like how it look.
I have a data set. I'll give it to you guys, maybe in coming classes.
Oh, sure. Yeah, one more variance of the same thing, Mani, is the
variance
of the same thing is delimiter being part of the column, right? So that also happens sometimes. Being like
delimiter part of the data. Okay.
Data, yeah. How do we ignore that? So maybe it is genuine, like or comma, yeah.
Comma is genuine. Yeah, that's a good point actually. That's an interesting question. How do you get rid of that? Yeah, it's fine. No, wait. It's okay actually. I'll tell you what happens. So let's say your name has comma. Let's say name. Oh yeah, actually some data will be lost.
Yeah, I should not split it as two columns. I should still get it as one column, right? So that's the thing I'm saying. Yeah.
That's a good point. Yeah, actually, some sort of before pandas also, I think it is important to get a quick scan of the data set actually. That way, then yeah, it becomes actually, yeah, that's a very good point. So let's say what I would do is sometimes it is impossible to come here and do it in pandas everything. Let's say, as you mentioned, the delimiter is comma and my name also has comma, right? Now, how will I leave that?
Will the comma be read inside a string?
Yeah, what is saying is something like this.
Because the data set we have been given, it's actually comes inside a string and then there's a comma. So if there is any comma inside a string, will that also be read in separator as a separator?
Yeah, that's what we'll have. Now, yeah, that's a good point. Now, what happens is, okay, who told that? That's a good point. So let's say you have name, but there are exceptions here. So there is age. What he's saying is, let's say the name is A comma B, not string, like just A comma B. And then again, age is 3. The name itself is A comma B, right? But when I do delimiter comma, actually I get name as A and the age as B, and then 3 is lost, right? What you are saying is another situation where name and age, if name comes like this within quotes, let's say this is quote, opening quote, closing quote, and A comma B, and then comma, and then age is 3, then it is fine. Then it will read. For example, if you see here also, if you see in the bank data.csv also, the unknown comes under quote. Correct?
Yeah, Mani, that the name A comma B will never come, right? If A comma B is there, then definitely it should be treated as two different names. Whatever comes inside quote, it's the actual name. If it's like A comma B, then definitely it is two different names. It cannot be a single one.
No, I'm just thinking like, is that possible?
No, because of the names, this one is given as a string, and if it's a comma is outside, definitely it's another part. It doesn't belongs to the same name.
Yeah,
I'll tell you why it is. It can be part of it. So first name come and last name, right? So people write that way.
No, what he's saying is makes sense. Surendra is saying, let's say even if your first name and last name is there, now what he's saying is name, when you put it in CSV, right? The first name and last name will also come within the quotes. So that's what he's saying. So first name, comma, let comma be.
Okay. Last, yeah. If it comes in quotes, I think it will read, right? Yeah.
Yeah. Then it will read as money, comma.
Okay. Yeah. If it is not there, then it is. We need to enforce, but we cannot know. Right? We cannot.
Then you are in a big trouble actually.
Yeah.
No, actually, it will not come at all, right, Mani? If it's not part of the quotes, definitely it should be treated as a different data set.
Yeah.
No, I'm thinking of this situation. Let's say you have to be open actually. What I'm saying is name, age. Think about this situation. Well and good. I understand that point. So let's say quotes are here, quotes are here. Now I'm just thinking of situation where will there be a situation where I get let's say people make mistake, right? So let's say first name, comma, last name, comma 3. Now what happens is this 3 is lost. Or what pandas does is it will create unnamed,
unknown or something, right? Unnamed, yeah.
And null.
Okay, Mani, the simple thing was if you're getting it from CSV, there's a comma also. Anyway, we are reading it from a CSV file. So inside a CSV, whatever it's in quote will be stored in one column. So definitely the other part will get it in another column. So definitely there is a distinction over there. So if we must be treating this as two different one. So it's not part of the same column.
Yeah, that I understood. What I'm saying is sometimes what happens is this types of weird situation where the person who was entering the data, he made a mistake. These mistakes are less, of course. If all of them are mistakes, then you can say the data is completely wrong, or you have to read it in a different way altogether. Now let's say out of 1,000 rows, everything is in quotes, everything is proper. Let's say first name, comma, last name, and then there is comma here, and age is, let's say, 6, 5, 4, whatever, fine. But let's say there is a new attendee or someone who doesn't understand. So he's filling the data, and he has filled by mistake first name in the name, and instead of age, he filled the last name in the quotes, and he went ahead and then gave one more comma and gave the age as 3. Now what pandas will does is it will create these 3 columns, and you will have null, 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 and 3 value here. Again, null, 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 null. Either you can drop this column, which is less. Either you can drop these guys so that you are working with healthy data. Or if you feel you want to keep this data, you're losing a lot of information, then particular columns, you have to write a specific function to fix this. That is also possible. Now, did I explain you like some rare situations where this can happen?
Yeah, I think, but some rare may not be able to handle, right? We may not be able to handle it.
Yeah, sometimes you, of course, you cannot handle all the situations.
Yeah,
Right?
that's
Sometimes
fine.
you forgo, right? Your main problem is not dealing with these guys. It's the person who gave the data, it's his mistake, but you should not go so much ahead that you are fixing only this. Your main problem was doing machine learning.
Yeah, correct, absolutely. Yeah, we can delete this row.
Sometimes it's fine. Let's say out of 1,000 you get 20 also, you can delete them. That's fine. If it is 200, then yeah, we are in trouble. Like you need to call that guy, or you need to fix yourself itself.
Right, got it. Yeah, okay, but if it's enclosed in double quote, no special treatment is needed. It just reads as in.
No, you can read it. You can read it. Pandas.
Okay, all right, thank you.
Mani, I have a quick question.
Yeah.
Like, could you just go to the Jupyter notebook? Yeah, under that read CSV, we have separator, right? So instead of that, can we use delimiter? So is there any difference? So I just tried, so it's giving the same output. Is there any difference?
I think it could be a version issue. Before there was a delimiter, now they are using separator. So there are many things actually. Like 1 second, let me check.
Both parameters are there. Separator.
They say separator as a string, by default it's comma. Again they say delimiter to use here. So let's see what they say about delimiter. Alias for separator. So it's just the same thing again and again. So what happened is in the initial versions there was, I think, delimiter. After the pandas 23, they have kept it as separator. So that, let's say if you have written code in 2016 with separator, and if you want to run it in pandas version 23, 0.23, it should not break, right? So they have given backward compatibility. So both are same. Alias means it's like a shortcut or same name.
Okay.
It's just a backward compatibility thing, so that whatever is written, let's say 2-3 years back, it doesn't crash. Let's say if I don't give that backward compatibility, if I write this code delimiter now, it will not work, because it will say that I don't know what delimiter means. It's a backward compatibility approach. Okay, guys, any other questions? Or else I'll close the class today. Yeah. Okay, guys. I'll also drop.
Thank you.
Bye-bye.